and not flat. Second, they can manipulate the environment. If you take a look at a legged robot, what is it? It's really 4 manipulators on a chassis. And the idea is that you be able to take any type of legged robot and teach it to do anything that you want to do. And third, legged robots are far superior in terms of energy usage, energy utilization on structured terrain. Why? Well, look, a wheeled or track robot might have to go around something, but a legged robot can actually walk through it. If they see an object and it's hard, for example, a rock, they can go around it or over it. But if it's porous, like a shrub, they should be able to walk through it. So the idea is legged robots are better on unstructured terrain, they can manipulate the environment, and they're more energy efficient. Unfortunately, the reality has not been kind. They're very complex, very difficult to work with, proprietary, and they're very, very expensive, and they've not been proven in the marketplace until now. And so Ghost has developed a design model that's size scalable, any size from a foot up to 3 to 4 feet. Short, skinny, tall, fat, long legs, short legs. 2, it's programmable, and we can take our legged robot and take the complexity out of it through an SDK and give it to the development community to create derivative works and make it better. And so we want to show you what we've created with our first version, the Minotaur. This robot was built at the University of Pennsylvania, half a dozen PhDs. And the one thing they were able to prove is that this robot can do all sorts of agile, highly efficient, maneuverable tasks without sensors. There's not one sensor on this robot. In fact, it's feeling everything through the legs directly into the motors. And if you see this provocative behavior, this was developed not by our team, but by somebody who took our SDK and taught it to climb a fence. But the biggest problem we have is that those provocative features, those capabilities, they're not robust enough. For solutions for the enterprise market, for industrial market, DoD, you need a product that is robust. And the only way to get to robustness is through AI. And so we use AI across the entire operational capability of our legged robot platform. This video is a little bit longer than I thought, so I'm going to shut this off and keep moving forward. The market is huge, and we're really focused on UGVs, unmanned ground vehicles. This is the version 1 robot, our next industrial robot that we rolled out at the AUVSI Defense Show in February. We were very fortunate, we won the award. Sadly, there was no cash, so we're happy to be here. And so that's our next version 1. Now, I want to show you a design of our upcoming version 2 robot. And our focus is security and inspection market across enterprise and DoD. And you can see this is one of our larger versions that we're rolling out at the end of the year. This is a slightly smaller version, a little bit softer. But the idea is that we can create any type of robot, any size, any platform, and let anybody take the hardware, the metal, and give the guts, the software, the AI, the capability of making this robot robust and do the sensor tasks, do all the necessary things you need with an autonomous robot, and open it up to the world. And the only way to do that is with the NVIDIA platform and our SDK. And you can see some of the DoD use cases that we have in the market today. And this is a use case that came to us from the military and FEMA. And we want to show you real quick, I'm running out of time, but this is our version 1 robot. I want you to check this out. A NVIDIA TX2 paired with, not a LiDAR, but a $500 Stereo Labs Z Mini camera. And this is live. This is live 3D graph mapping. It understands that it's a human. It starts taking a thermal camera, a simple $600 thermal camera, nothing fancy, with the right AI software. And by the way, that was our intern. He's not a bum. And we were able to tell quickly in 2 weeks and write an application where the user, where we could recognize the heart, the breathing rate of a person. This is our stack. I know I'm running out of time here, but real quickly, everything we do has to be AI enabled. And so we believe We are entering the next generation of robotic development by using AI to get to 5.9 robustness. This is our roadmap. This is my favorite slide. We have customers today, and we're building new prototypes and new applications with many of our partners. And this is the market positioning. I apologize, folks, my video ran a little bit too long.
Thank you, Julian.
This is the great team that
We have time for 60 seconds. Questions from the judges, please.
So, is that robot, is it running on a Jetson platform already?
It is, and we can put 1 to 3 Jetsons on the device.
And what do you think is your secret sauce? I mean, obviously it's a pretty cool robot. You said you can do any robot. That sounds pretty ambitious.
Yeah.
What is it that you guys figured out that nobody else knows how to do?
We took the complex control platform and the ability to write the AI applications at the task level for sensors, for the autonomy, and the operations of the leg and robot, and put them into an SDK. And we think that's really the secret sauce, is the electronics, the firmware, and really the software stack. Not